Hello students, welcome to today's session. So in this session we are going to see about the neural network architectures and its algorithm. So first we are going to see about supervised network. So what is meant by a supervised learning network? So it is the training and test data sets have been already input, data has been given or specified. So this training sets and the input and the test data. So what are all the data we are going to calculate, which are all specified already. So we have known what is the input and also the data. So this is what a supervised learning network. So based upon the data, the machine will learn and act accordingly. So this is the input data and example outputs. So the training process will happen based upon the number of inputs, so which is already given. So the processing speed and also the idea where the output has been modified, output has been declared or output has been chosen with the help of these input data and the based upon the computation process. So here the training process is very much easy because of its because already the inputs have been specified already. So we know the inputs. So for these inputs, what type of summation or what type of calculation has been done based upon the given data, right? So and then the results will be available at the end. So this is the one of the network is perceptron networks. So this type of perceptron networks is one of the type in neural network system. So here the perceptron which computes the sum of weighted combination of inputs. So here the weighted combination of inputs, here the x1, x2 and up to xn, these are all the inputs, and w1, w2 and up to wn, these are all the weights. So it will compute with the help of the bias value, which is the added value, into the summation. For example, this is the summation network. So here the weighted inputs will be calculated and the output will be specified with the help of the bias value. So here the combination of inputs and its sum is greater than the threshold value. So then its output will be positive 1. So if the sum, the data, input data is greater than the bias value. So the bias value is the constant value which is given and it is the threshold value. So the output will be 1 or true in case of the value which is greater than the bias value. For example, if the bias value is 1, so the output will be the input total calculated input will be 2, means the greater than 1. So 2 is greater than 1. So the output will be modified as 1. The output will be chosen as 1. Otherwise, if the output is input combination of input is less than the bias value, so the input will the output will be minus 1. So the perceptron network which computes the sum of the weighted inputs, combination of inputs. If the sum is greater than the threshold value, so then its output will be 1. So this is the unit and network, and here the linear threshold unit. So here the threshold unit is based upon the number of bias value and the combination of values. So here the summation and the input value, which is I is equal to 0 to n. So n value will be the number of inputs, and which is the combination of weight into number of inputs, that is wi into xi. So for the activation function f of xi will be equal to 1 if it follows the condition I is equal to 0 to n will be greater than 0, otherwise minus 1. So it is less than 0 means the output will be minus 1. So this is the person. So here the weight value will be calculated, and here the change in value will be maintained in del value and del wi, where del is equal to. So here the weight value will be changing. Change in weight is given by a eta, that is a small constant, and t is equal into t minus o. So o is the perceptron output, which is multiplied by the x1, xi. So xi will be the input value. So t is equal to c of x. T is the target value, which is the constant value, right? And here the eta is a small constant. For example, 0.1, which is called a learning rate. So the condition which is satisfies when t is equal to 0, the output will be corrected one. So the weight wi will not be changed. So if the output is incorrect, that is t is not equal to 0 or o, the output weight will be changed. So such that the output of the perceptron networks for the newer weights will be closer to t. So this is the condition. These are all the two conditions. So this algorithm converges to the correct classification because if the training data is linearly separable, so and it is sufficiently small, the eta value is sufficiently small. So these are all the two conditions where the algorithm converges with the two data. One is the training data which is linearly separable and eta which is sufficiently. So here the learning algorithm, that is approach or iteration, will be based upon the presentation of the entire training set to the neural networks. So for example, if you are using zeros and ones, so the combination of 0, 0, 0, 1 and 1, 0 and 1, 1 in case of the AND function, because the two input AND function, so this kind of iteration will be presented to the network. So the approach which is consisting of 4 sets of inputs that is being presented to the network. So here the presentation of the entire training set to the neural network, entire neural network in case of the AND function. In case of OR function, it is depending upon the output. So here the error value. So error value is the amount of value which is different, which is calculated by the output with the help of the target value. So the error value is the value which is amount of value which is given by the output by the network, which is differed from the target value. So the error value which is calculated with the output and also the target value. For example, if the error value which is equal to -1 means the output is 0 and its target value is 1. So this is what the error value which is calculated. So if we require the network to output 0 and output 1, error will be -1. So this is what the learning algorithm. So this learning algorithm has the target value when the training network, so we have to fix a target, right? So here the in the training a network, we not only present input but also the value which is required to produce. So for example, if we present the network with the value of 1, 1 in case of AND function, the training value will be 1, because in AND function, so both the values were positive or the output will get a positive value. And then the output 0, so output or O, the output value which is the value which is derived from the neuron, and also Ij which is the inputs which being presented to the neuron, and Wj is the weight which is from the input neuron, and this weight which is depending upon the values of the output neuron, and also the learning rate. The learning rate is which is dictated by the network convergence. So and it is a set of matter of experimentation. So it is a typically 0.1. The learning rate will be less than 1, and the training algorithm will adjust the neural network weights to map the input, because the mapping the input and with the weight will decide the output. So using a set of sample patterns where the desired inputs, that is the given inputs, will be known. This is what a supervised training algorithm chosen. So the inputs are already given, and based upon the inputs the training will be happened. So the purpose of this training algorithm is to recognize the features which are common to good and bad examples. So this is what training algorithm chosen. So the multi-layer presentation. So far we have seen the single layer, and if the multi-layer is depending upon the output values and the adjustable weights. So input layers having a external stimuli. So these are all the input layers, and the adjustable weights based upon the condition we will make the output layer, and based upon these the adjustable weights and input layer, the external stimuli, that is the input signals, so will be calculated. So this is what the diagram which is representing the multi-layer perceptron. So the 3 layers in the network, the one is the input layer, and another one is the hidden layer, and the last one is the output layer. So here the input layer will introduce the input values into the network, and there is no activation function because it is an input. So without input we can't do the function, right? So here there is no activation function or other processing in case of an input layer. So second layer is the hidden layer. So in the hidden layer the performance will be based upon the classification of features. So what kind of features has to be done, what kind of values has to be calculated. So this is what hidden layer, and 2 hidden layers are sufficient to solve any problem, and there are more number of layers will be used for better experience. And also the output layer, the last layer, which is the functionality like a hidden layer, but it is connected with the outside neural network, right? So here the outputs are passed to the outside world with the help of the neural network. And then this is one of the algorithm, that is Adeline, adaptive linear neuron. So this was developed by Bernard Vidro and Marcian Hoff. So in the Stanford developed models, which is called the Adeline and Madeline. So Adeline is adaptive linear neuron and Madeline is the multi-layer adaptive linear neuron. So these are all the two models which is used for multiple adaptive linear elements. So Madeline was the first neural network to be applied to the real world problem. So it is an adaptive filter which eliminates echoes on phone line. So this is what Madeline used. So this is the Adeline model. So it is having adaptive algorithm and output error generator. So here the feedback which is given from the output layer is generated to the with the help of a output error generator, and it is again given back to the algorithm input layers through the adaptive algorithm. So it is a learning supervisor. So here the training sets are introduced, and already the so here already the input layers with a bias and W1, W2, which is the weights. So summation y in, summation of x into I, and this is the function of output. So y is output and is the function activation function. So this is the model. So it is having a rule. It uses a delta learning rule. So this is also called as a least mean square rule or Vidro learning rule. So this delta rule is used for adjusting the weights which is given from I, that is the summation 1 to n, right? So here the del wi is the weight change, and alpha being the learning rate, and x being the vector of activation of input unit, and y in is the net input to output unit. So there is a y is the output unit and y in is the net input to the output unit, that is equal to summation of I is equal to 1 to n and xi into wi, and t may be the target output. So here the using Adeline networks, so we are having a three stages. One is that initialize and training and taking. So in the initialize stage, assigning the random weights to all the links. So we are choosing the weights to all the remaining stages, and the training which is feed in known as which is the known inputs, because it is a supervised learning network. So we are already feeded the inputs, that is the known inputs and in random sequence. So and then in order to simulate the network and to compute the error between the input and output, this is the error function. So and in case of adjustable weights, there is a learning function, and repeating until the error, so which is total error which is less than the value. And then thinking is to stimulate the network, and the network will respond to any input, and it does not guarantee a correct solution even for the trained inputs. So this is the thing. So Madeline network is a multi-layer adaptive linear element. So it was the first neural network to be applied to the real world problems in case of phone echoes. It is used in several adaptive filtering model. So it is that during the training process it will be behaving like the multiple adaptive linear elements. So and then the back propagation. So back prob implements a gradient descent search through the space of possible network weights, and it iteratively reducing the error with the E and between the training example and target values and network outputs. So it is guaranteed to converge only towards a minima. So and then the back propagation, it is a training procedure like multi-layer feed forward neural networks. So it can theoretically perform any input and output mapping and can learn to solve the linearly inseparable problem. So this is the multi-layer feed forward network. So here the inputs I1, I2, I3. So for example, we are giving I1, 2, 3, and then H1, H2, H0, H0 and H1 and H2 are the hidden layers, and O0 and O1 which is the output layer. So this is the multi-layer feed forward network. So here the combination of inputs will be based upon the number of hidden layers. So here it continues like a function which is allowing the gradient descent method, and it is an example of gradient descent technique. It uses sigmoidal, that is binary or bipolar activation function. V1 is the vector of input values x1 and xn, and for the input instance there will be the values. So for each linear unit weight, minus del I will be the change in weight. So most of the modes of the gradient descent is batch mode, incremental mode, and it is depending upon the weight. So this is a sigmoidal function, and back propagation training algorithm is back propagation application, has been used in load forecasting problems in power system and image processing and fault diagnosis and fault detection and signature verification with structural engineering design and gesture recognition and speech recognition. So this overall the learning networks, supervised learning networks, we have seen perceptron, Adeline, Madeline and back propagation network. So apart this, there are other supervised learning networks. You can study the tree neural networks and wavelet neural networks and functional linked neural networks. So these are all the combinations. So far we have seen the supervised learning networks. So thank you for watching. Have a nice day.